Okay, for people joining this live stream, we are talking about incremental language development for Wolfram language. This is a series of meetings which we've been having, as it seems, from the first item on our agenda for 5 years now, and it's delivered many important features of Wolfram language. We'd actually stopped these meetings for a short while because we just finished version 12.1, and we've not been focusing on new designs for a little bit, but we are restarting. And even in these pandemic times, we are steaming ahead. So let's take a look at, okay, this seems to be a summary of things that are in the ILD area.
Exactly. So these are things that are moving on right now, and we could discuss a bit of priorities.
Okay. All right. Hey, you know, it'd be really good to solve the whooshing problem of microphone whooshing problem. But in any case, all right, and actually, hold on 1 second. I have to solve a small problem here. Just a second. Hi. Okay. FoldWhile list. Okay. Is that a comp? I mean, yeah, go ahead.
This is a function which is almost done. We are just reviewing the last two arguments, which are the arguments that handle how many more elements or less you get.
Right. Okay. Echo timing. So do we have a design for what echo timing is going to generate as output? And another question about that. So, you know, I end up finding that I do copy paste of echo cells from notebooks. And two things there that we should probably think about. One is what happens when you copy paste an echo cell, and the other is what happens when you do a notebook import when you have echo cells in the notebook. Both of these seem to be okay, but I'm just not completely sure that we've got it exactly right. And for echo timing, I can see the same type of thing. That is, if we are trying to, let's just do an echo here. Okay, so now I do a copy paste here. You know, what am I copying here and where does it copy to? Does that copy? That copies like that. Now, if I copy the whole cell, maybe I'm just confused here. Okay, but one thing that definitely doesn't work, let me show you something that definitely is pretty ugly. If I say parallel evaluate here, oh God, it's going to launch all of my compute nodes here. Okay, this is about to be pretty ugly. And I don't know exactly how it's transporting from the parallel kernels the echo cells.
I see.
I mean, stupid. It's what I get for having. I think I've got 93 cores right now active. Well, it means that when I do a computation, it's about 100 times faster than it would otherwise be, which is quite useful. Okay, look at this. See that greater than sign? That's really ugly.
Right. This must be using what we use in the terminal.
Right. And I you know, be better if there was some, I don't know how this is being transported. If we could look at that, that'd be great.
Right.
And clearly when we do a copy of this, we're getting some ugly string type thing that's, oh, that was a copy of a cell, but let's see what happens if I do that. Then I will just get a string copy, right? Yeah, that's really ugly. So that would be nice to avoid. At the very least, let's just send through a Unicode character there. But it still would be better to not have it at all. Or if we could, if we have to do it in some hacky way there, we could send through a Unicode character that disappears on evaluation or something. Anyway, this is a minor corner case. I just point this out. Okay, do we in fact have a styling for echo timing or not yet?
I think we do. We are adding it right now. So I think next week we will be able to finish this. I mean, there's a pull request open to add it's like a clock.
Okay, don't make it too heavy. I mean, we really don't need a giant, grandfather clock image or something. I mean, just a very, very light thing like that.
Mm-hmm. I think it's a Unicode.
Okay, fine. Nothing too cutesy. Jose, you should get somebody to help you debug your wind noise thing. I don't know. If I knew more about audio engineering, I'd be able to tell you what it is. It's some kind of gain thing or something. Okay. Okay, attach coordinates. Partial code below.
Yes, so I mean, if you want to go into details, there is code at the end. So this is a function that takes an array of values and a range of coordinates, and it will return.
Yeah, this is a useful function.
Right. Yeah. And we will do this for numbers, quantities, dates, and multiple other things. So.
Good. Right. Okay. Pair applied, head map, this whole thing. Right. I mean, again, yeah, I mean, that's primarily a naming problem.
Exactly. Yep.
Right. Which is, okay. Well, we're just surveying what we're doing here. So, okay, extract with default.
Yes, so this is another thing we started to discuss in the last meeting. And the problem is that we don't want to follow the precedent of first by adding hold rest, because that would spoil the second and third argument.
Yes. Well, unless we just evaluate them, unless we have a nominal hold rest, but just evaluate them.
Yes, we could, but it would be strange, I think. I mean, I would prefer if we don't have that.
Okay. Well, all right. So listen, for purposes of what we're trying to achieve right now, let's just survey this quickly, and we're deciding which things here involve design discussion, which things here involve something else. Okay, splice for multiple heads. I really would like to see this happen, the spliceable thing. I was talking to Roger about that yesterday, about the issue of essentially switching off listability for symbolic vectors, which is kind of the inverse of spliceability, not the inverse, the negation of spliceability. So I think that's a topic we need to discuss, is spliceability and essentially wrapping lists to prevent listability. Makes sense? Okay. Well, so let's keep going with your survey list here.
So this is another big discussion that we had a few meetings ago. And so here we want to have these new functions, and it's not clear whether we want to go these column functions or adding a symbolic spec.
Look, I mean, my basic point of view here is Dataset is very powerful, but comparatively hard to use. The question is, what can we do to make, I think we need to kind of zoom out a bit and think about what do we need to do to make Dataset easier to use. And this may wind up, dovetailing with that as we build things which are, for example, natural language input forms or a lot of auto-suggest forms for queries and so on. I think this will dovetail with that. Does that make sense, or am I off in the wrong direction here?
Yes, so Dataset certainly will offer a new point of view. Yes, I think we will still have the issue of what to do with structures like extract, etc., which are not Dataset.
No, I understand that. But I mean, I think the question is whether we need to signal with the word column a bunch of separate operations like column total and things like this. Maybe we do. I mean, they're common enough that maybe they're worth doing. But I think if we do that, it needs to, column total certainly needs to work on a data set. And maybe we will learn something from trying to do the more general design for data set. So, but I think that's if you're asking, is this something we should be covering in ILD? The answer is obviously yes.
Yeah.
And that's but that seems like a fairly complicated discussion.
It is. We have had that discussion a couple of times already, and yeah.
I mean, this is always this is a design-heavy discussion. I mean, everything we're seeing so far is design-heavy, not particularly implementation-heavy.
Right. Mm-hmm.
Okay, uncertainty.
Yes. So here there are three directions in which we want to go. One is typesetting of around objects, because they can be given in various ways. And for this, we need, I think, an around form function, following what we do with quantity form, or with numbers, with number form.
What are we doing? Do we even have a quantity form? I don't think we did.
Yes.
We do.
Mm-hmm.
Oh my gosh. I'm sure we designed it here.
Yeah, it's not used a lot, but there are cases where you may want to print it out with the full unit name instead of the short form, or you may want both of them potentially.
I want to comment on something about that. I'm finding a bunch of these things. If I type in 6 meters, for example, here, and I get this, I don't know. I mean, this form. But actually, this isn't the case I'm really complaining about. Let me type in mass of the Earth. Oh, that didn't do what I was expecting it to do. Okay, here's an example, like Planck mass. Okay, that's pretty weird. I mean, like the one there is pretty weird. The fact that, I mean, I guess m sub p, or actually, here's a worst case. Okay, that's crazy. The fact that it says 1 times c. Why does it do that? Why isn't it just c?
So you can see in the control equals pod, it just shows up as c, and that's because we have a general typeset form for physical constants that when they come back parsed, we basically know that you want a single value of them. We still haven't generalized that typesetting for all instances where you have a 1 value, because we don't have there's an implementation element of it, and there's basically a general design question of, do we want to just say 1 times any physical constant always just shows up as the physical constant's abbreviation?
I think we do. Well, okay. The abbreviation is a kind of weird, because if I'm saying E equals M, and then I want to say, I don't know what happens if I just say C here. It doesn't I wonder whether I get offered. Okay, so unit is kind of a weird thing here. That's probably the speed of light, right?
Yeah.
That's a weird, even calling it a unit there is kind of wrong. But then I do that. Okay, that's really a lose.
Yeah.
I'm pretty unhappy with that. And I don't even know what this means with I mean, that's distinctly bad.
Right, so the underlying problem here is that we treat constants through the quantity framework. And so we treat them as units. And so, I mean, you can say twice the speed of light, which is nice.
Sure.
But,
and we want that. I mean, 0.8c or something is something we want. But I'm just saying, purely as a typesetting matter, we don't want this. We don't want the parens and we don't want the 1. See what I'm saying?
Yes.
Yeah, we've done some work like in the formula data framework to try and clean some of these up for common formulas. But I do think basically what I need to do is work with Eric and have some sort of internal markup to differentiate physical constants from general units.
Let's do it. And let's get this cleaned up.
Okay.
I mean, I'm also concerned that oh, that's funny. That was that E isn't the E I thought it was. I guess I'm also concerned about that there are cases which I found that are much more bizarre than this. I mean, the C is a little weird that you just get back a thing that says C that's sitting there, but there's some other cases that are much stranger where I'm let's see if I get what's a good example where I just get back something that is some quite obscure abbreviation that I would rarely actually abbreviate in practice. Gosh, what's a good example? Well, let's say Hubble time. I guess it's okay. I mean, I guess whatever, you know, it's a notation for that. I guess it's all right to put it out in that form. I think I've had some slightly stranger examples of this.
But do you agree we want the constant and not the value, the physical value of the constant?
Oh, definitely. We definitely do not want to evaluate this. Okay, yeah, there's another issue here, which is when I say unit convert, okay, so fine, that goes to seconds, but there are a lot of cases where I've got, well, okay, so let's imagine I've got, you know, the Hubble time divided by c squared or something. Oops, wasn't what I wanted at all. Hubble time divided by c squared. Okay, so I have that slightly strange formula. The question is when, if I say 2.7 times that, okay, I probably want, that's fine. You know, unit convert is a slightly strange thing to say to get that evaluated. Oh yeah, the other issue is, oh yes, this is the other issue. The other issue is when do I get, so let's say I say 5 miles per hour, okay? I mean, first of all, that's pretty odd. mi/h is pretty odd, but fine, I can live with that. Let's go 7 meters per second, okay? And let's say percent divided by percent. Oh, actually did the right thing. What happens though if I have non-commensurate units here? So if I have something where I'm going, I mean, one of the annoying things is that I might have 5 miles per hour divided by 6 meters. And then there's a question of what units I end up getting. Well, I can't complain about that either. Okay, actually 2 interesting comments on our live stream here. First comment is n of %29, n of the speed of light. Yeah, that's a complicated story because I can absolutely imagine saying 2/3 the speed of light and being quite annoyed that, you know, I mean, numerical evaluation is sort of a different story from evaluation of the constant.
Right.
And I mean, unit convert is basically going to base units, right?
Right. By default, if you don't specify target, it will go to the SI base units.
Right. What does it do, like, for if I say oh gosh. I mean, correct, but rather weird.
Yeah, temperature is a complicated case that we're looking at a larger design discussion about differentiating different use cases for, but in general, for in an absolute temperature, the base unit associated with it is Kelvin. So
yeah, right.
Kind of big
Look,
values.
the issue here is for these physical constants and so on, you know, I think n, the mission of n is numerical evaluation. And okay, you might argue, why is it the case, this is a very philosophical discussion, that n of pi turns into that, but n of c does not? Gosh, the scary thing about this is with the whole new physics theory, we actually could do, yeah, I mean, it actually kind of makes it seem like the c is closer to a pi than to something else. But I think it's odd to, you know, okay, the argument is, why should n of pi evaluate? Because it is going to give a number, but n of c, which could give a united quantity. See, the thing is that most united quantities, if I say something like, you know, density of osmium or something, because these are measured quantities, basically, they are always numerical.
But in a sense, they are never numerical. It's just that you are converted into a different quantity, in this case, grams per centimeter, cubic centimeter. So it's not a matter of numericizing. It's a matter of choosing a better unit.
Well, but here's an argument. It could be the case that let's say the density of gold could be a fundamental, could be something that in our unit system, well, mercury, for example, in millimeters of mercury, right? Effectively, the density of mercury is something like a unit. In other words, we could imagine wanting to carry around density of mercury as a symbolic object without converting it into whatever it is, 13.6. Is that right? Oh, I'm forgetting. It's 13.6 grams per cc, isn't it?
Right.
Let's check that neuron is still alive. Oh, really? I'm sure it was 13.6 back in the day. Maybe it's different temperature and pressure. Okay. In any case, but I mean, the whole point is we're not carrying this around symbolically. It's different from speed of light, which we are carrying around symbolically. See what I'm saying? And I could imagine something where there is a computed thing, which is, well, like what do we do for the Bohr radius? Oh gosh, we just do that. But for example, how would I get the Bohr radius expressed in terms of h bar, m sub e, and so on?
For that, you need to use the entity physical constant, I think it's called. So all these constants have a corresponding entity, and the entity knows lots of relations with other constants.
Okay.
So this is the sort of thing that Michael was working on last year or 2 years ago, when there was a change to.
Well, I think we should. Okay, let's set up a separate meeting to discuss this. I mean, I think there's a bunch of issues here. I mean, there's 3 levels here. One is we just evaluate the density of mercury to a quantitative number. Second, we carry around the speed of light symbolically. Third, we have the Bohr radius, which can be represented as its sort of source symbolic form, but it can also be represented, like if I were to say, it'd be very weird, but if I were to say function expand of that, I might expect to get, something in terms of h bar and so on. Although function expand is kind of a weird name, just like unit convert is a weird name to go from this, combination. I mean, if I take this thing here divided by the speed of light, right? How do I get, so now I want to convert that. If I say unit convert of that, what's it going to do? It's going to give me base units. That's a weird quantity. That's like the electron charge. That's really weird. I didn't know it would come out like that. Okay, now for my utter confusion, let me just, electron charge is like 10 to the minus 19 coulombs, isn't it? Okay. Okay, so that's a little weird. So now I would have to say unit convert. Oh, for goodness frigging sake. Okay, great. Now how do I get it in coulombs?
Unit simplify, perhaps?
I didn't even know we had that. I've obviously not been using these things enough. You are absolutely correct.
Yeah, I mean, I could imagine, I don't know if it would be for unit convert or unit simplify, but having, I guess natural units would be a bad name for it, but sort of a canonical value, because a lot of units have sort of their fundamental base value in SI, and then they also have sort of a natural definition form. And we don't have an easy way to access that form currently in the language.
What do you mean? You mean like seconds, ampere seconds? Which, and this is also wrong. This shouldn't be S times A. It should be AS, shouldn't it? Isn't that the SI convention?
Yeah, I mean there's some complications with typesetting, and I know you mentioned we should probably have a separate meeting to dive into this a little more. So I don't want to get too sidetracked.
Okay, all right, fine.
Yeah.
But let's make sure this is in the notes from this, and let's separately discuss this.
Yep.
can also do Coulomb in the second argument to unit convert.
I'm well aware, but
Okay.
I don't want to have to do that. And I mean, you know, like if I say, let's try doing something like this. If I say viscosity of, let's take something a little bit obscure, let's say benzene, just because I don't want to do something trivial. Okay, so that's second pascals, but that's not in poises, right? So if I say unit simplify, am I going to get that in centipoise? No, I'm not. I don't know why. Okay. Well, in any case, yeah, another discussion on this stuff. Okay, a couple of comments in the live stream I want to look at. One is Sammy here commenting on a way of entering 6 plus or minus 1. Yeah, this was a huge discussion when we built around. You know, what is the infix form of around? What did we do finally with A? If we say escape plus minus, that gives something different, right? We agreed not to use that for around because we think plus minus is an algebraic plus or minus, which is different from the uncertainty plus or minus.
Well, not even an algebraic one. It's something that we have there for the user to use. I mean, in chess, for example, they use also plus minus notation. So plus minus doesn't have any meaning.
Yeah. Well, okay, fair enough. But I mean, the question is there some more convenient way to enter an around form than typing around? I mean, do we have an infix form for around?
No, currently we don't. And for example, another thing that people have suggested is that around objects should be editable, which is also a good idea, though.
Yeah, it is a good idea. Yes.
Not easy because when we have there 1.0, we don't really know whether that's 1.0 or it's 1.023.
Can I ask a question? Would it be completely crazy? I mean, in other words, is around popular enough that it would be worth trying to create an infix form for it? And the infix form I could imagine would be something like plus dot minus, which I believe is unambiguous.
Could be, but I mean, you mean without an escape?
Without an escape.
Oh, wow.
I mean, I think it's I mean, I don't know. We have to, you know, it's a popularity contest, basically. Brian on our live stream is suggesting at plus minus. Is that unambiguous? Don't think that's unambiguous. F at plus minus x, I think, is parsable. Yeah, it is. Sorry. I mean, we could certainly have an escape form of this as well, but I think we could, I mean, you know, should we consider this as a non-escaped infix form?
I wouldn't oppose it. I mean, this requires probably people from the front end to discuss. But I mean, it would be great to have better interactivity with around, of course.
Yeah. There's a question on the live stream which I don't know the answer to, but what happens with this? What does natural language input do with that? Ooh, interesting. That's interesting. Different team than the one that's on the call here. What should 6 plus minus 1 do in natural language input? Should it give an assuming? Probably it should.
Yeah, I think so.
So that's something we should feed to the natural language understanding folk. Good point. Thank you for that suggestion, Ben. Okay. All right. Let's continue here. Okay, a round form.
Yes.
So do we have a design for a round form?
Not yet, though it's more or less clear what it should do. The things that are needed here are first the discussion of how many digits to show, and people have sent suggestions about that. Second, the confidence levels, because when we say plus minus 1, that means one level, one confidence level, 1 sigma. But people sometimes want 2 sigma or 3 sigma.
Oh, I don't know. Does it really mean 1 sigma? I mean,
Yes.
it means the thing that is in the calculus of arounds. I mean, are we really in a position to tell them what the 2 sigma? I mean, clearly the actual probability distribution is getting smashed around as we, propagate the around through different operations.
Yes, there is always an approximation that this is being approximated by a Gaussian. It is approximated, totally true. Yeah.
But I mean, is it the case that given 1 sigma that we can compute what the 2 sigma level is just as an algebraic multiple of the 1 sigma value? I mean, is it literally 2 times this 1 sigma? I mean, is the 2 sigma version of 6 plus or minus 1 6 plus or minus 2?
Yes, but you have to
Okay.
say in parentheses 2 sigma to indicate that you are covering.
Or you have to say something like 95% CL or something.
Exactly. Yes.
I see. So people want basically to display. How will this work with our actual official probability distributions, where we really can give genuine confidence level intervals?
Yes. So a round form will take an option that says, in various forms, give me 93% or give me something, and then we give the plus minus with the correct number, and in parentheses 93%.
Yeah, I understand that, but I'm saying if we actually compute it from, I mean, if I were to compute, I don't even know how to do it here, but if I have an actual normal, let me pick some slightly weird distribution, I don't know, a Weibull distribution, and 2 parameters, okay, 2, 1, okay, great. So now here I should be able to say, what is the actual thing? Can I type confidence level? Okay, is that the right thing? Confidence range? I don't actually know how to compute it. What is the right thing to compute here?
Well, I guess it will be a CDF with some value.
I see. Okay, fine. Okay, so the CDF of this with value. No, but that's not what I want, because that's in. Okay, but in any case, there's a definite. I mean, my question is, given that we're actually computing from an actual distribution, we can give an accurate, 93% confidence interval for this.
Mm-hmm.
And the question is, when will we want to use that display form to represent that? I mean, the display form you're proposing is an elaborate display form specific to around. I guess, I mean, the issue is, when would a thing like this return an around? If you're characterizing this distribution, okay, is there any way for me to get, given if I say around of normal distribution,
Yep.
of 3, 0.4, then I will get a beautiful around there,
Yep.
right? If I say Weibull distribution, around of a Weibull distribution, oh my gosh,
Right.
that's amazing. Cool.
Yes. So what it's doing is it's computing the mean and then something that is a description of the width and asymmetry.
That's really cool. Okay. I mean, now that I'm seeing this, I'm remembering we discussed this. What does it do for a discrete distribution? Does it work there too?
I don't think so. But I don't know what it does. I cannot predict right now.
No. Okay. Yeah, it's less clear what you should do in a case like this.
Mm-hmm.
Okay, well, cool. I mean, that removes my objection, because then you can use a round form just fine with a Weibull distribution and get a reasonable result. Okay. Steve on our live stream is noting that around is still marked as experimental in the 12.1 documentation. At some point, it's time to promote it.
Yes, the main issue is the third one in that list, which is, I mean, I know what to do with the other two, but the third one is really hard.
Okay, well, I mean, the other issue with it is supporting around in more places, particularly in the fitting functions, statistics, other places like that.
Yeah, that's true.
Yeah. What is happening with that? Is the statistics team working on that, or who's supposed to be doing that?
Yeah, it should be them. I think they are at the moment too busy with geostatistics.
Mm-hmm.
But yeah, at some point they should be working on this.
Okay. Okay. A round value. What is this?
So this imitates date value, and the idea is a bit of the opposite. Given an round object, compute many things from it.
Such as its central value, such as whatever.
Right. Or for example, right now we can compute some of them, like an approximated number, approximate interval, etc., with a method, just by adding a sub-value string at the end. But what happens if you want to do it with an array of many of them? We need a function to.
I see. So the analog of sort of an entity value type thing.
Exactly.
So for this, what are the string values? Oh, they're right there. Okay. So for example, uncertainty here will just give us 1. Okay, fair enough. And so the issue is to get a function version of this. Sounds reasonable.
Mm-hmm.
Okay. What is this horror about handling of non-linearity?
Right. So the formulas for propagation of errors are using linear approximations. And a round replace already has a second argument in which you can increase the propagation order to 2 or 3. And I have formulas up to 4. But people want to use this in really, really nonlinear situations. Like we have bugs complaining about, oh, a round doesn't work in the jump of a theta function. And I don't even know what to do there.
Okay, well, let's take a look at what the issue is. Okay, so we got a unit step, for example, and we say let's take the okay, great. There's our unit step. All right, so now let's understand what the around computation that people want to do is here.
Right. So imagine that you have a round of 0 plus minus.
Okay, 0 plus minus 5, and now I want to feed that into a unit step.
Exactly. So this fails miserably. But I mean, to do this correctly, and you see the univariate case could work because we can do effectively what our numerics is doing, which is using some sort of interval computation. But what happens?
Well, what do we think the answer is supposed to be here?
Well, users want something like 0.5 plus minus 0.5.
Really? Why? Because they know that the actual values are. I mean, so what happens if I do sine of around 10 to the 10 plus minus 0.2? Is that going to work?
It's going to do something, because in this case probably you are in some random point of sine. This gets problematic if you do, for example, do a round of.
Okay, that's obviously wrong, right? So
right,
no, but
right.
Look, that's obviously wrong.
Right.
So the question is, what is the because right. That's using linear propagation, or is it quadratic propagation or something of errors?
Right, by default linear. Now,
so how would I do this to second order? Can I do the same thing to second order?
You can do it with not directly. It has to be done with a round replace.
Okay, so if I say a round replace
Sine
of sine x, and then x goes to, is this what I want to do?
Yep, around.
And then the surround here.
Yep.
And then what do I do? How do I specify the order?
As an additional argument, comma
2. Okay.
Yeah, I mean, it's what the formulas give. It's just, I mean, try to increase it to 3. Let's see if it goes better.
I doubt it will. I think it'll go worse.
Yeah.
I think it's a non-convergent story here.
Right, probably.
But I mean, so the question is, we can't, in fact, okay, so we know a constraint in this case, that sine has to be between plus minus 1, at least assuming that the around is on the real line, right, which is what we're always assuming, right?
Mm-hmm. Yep.
So the question is there any way to propagate in function domain constraints, so to speak?
Yes, and I think for the univariate case, there is. We can do better here. But
how?
Well, effectively by doing an interval computation, by making sure that the interval computation is always the worst case scenario. So if the
I see. So, but wait a minute. But that is assuming. What would you do? You take the 1 sigma or the plus minus values, and you would do the interval computation for the plus minus values and use that.
Exactly.
And you would do the interval computation for the plus minus values and use that.
Exactly.
And you would do the interval computation for the plus minus values and use that. And you would do the interval computation for the plus minus values and use that.
Exactly. compare that.
Why is that the right answer? Because I mean, that's assuming basically that it's a, you know, a square wave, whatever, you know, you know, some kind of square wave distribution, right? Which just goes out to the plus minus values and then goes to zero out. The PDF goes to zero outside of that.
Right. Yes, but sorry, I said it wrong. It's not sigma. It would be like effectively x plus minus infinity, and the sign would say, "Oh, you are between -1 and +1."
So, so it would puff out the actual interval to be the infinite interval,
right.
and then say, given that, so that will work for sine. And I mean, these functions that have finite, I always forget, range, right? The target.
Mm-hmm.
So these functions with finite range, you could say that is the range of the function. Don't we have a function range? Don't we know symbolically what the range of those functions is?
Yes, I think we do.
What is it called?
If not in system already, it's certainly something that is being added internally and in the future system.
Okay, but so the point then is, what you're saying is, for those functions, we could bound. I mean, have you talked to the Rogers algebra people about this? Do they have an idea what we could do? I mean, what you're describing is, okay, how would you know you're in trouble, so to speak? Because most of the time, you don't want to be messing around doing some weird algebraic computation about the possible limits of the function. You just want to be following the error propagation formulas. Right? So how would you know you're in trouble?
Well, there are two possibilities. One is to do a fast numerical computation because our numerics also has error control. So that could give an indication. The other one is by realizing that we are getting too small values for derivatives compared to what an average derivative is for that function.
Explain that one to me. I mean, so in this case here, where we have, I mean, what happened here? I mean, clearly that one we can tell something went wrong.
Right. Yes, but for example, another case is having sign around a horizontal point.
Mm-hmm.
Because the derivatives are 0, then the errors, we get zeros. And of course, we cannot get 0 errors.
So you're saying sine around of pi over 2,
right.
comma, 0.6 or something.
Right.
Oh, wow. Interesting.
It's
okay.
Too small. So we can do some heuristics. And as I said, I'm sure the univariate case can be solved. The problem is the multivariate case with correlation. That I have no idea how to attack.
But you see, ultimately, this is kind of, I don't know, the immediate analogy that's coming to mind, maybe because I'm thinking about other things, is computing Hawking radiation using quantum field theory around a classical black hole. I mean, we've got two different kinds of approximations going on here, and it's I mean, I think it may be just undoable, because it may be that, yes, you can do the exact symbolic computation, but as soon as you throw yourself into this kind of calculus of error propagations, it's just a different thing. And I'm not sure it's going to work to try and combine those. Why do you think that this sort of symbolic limiting is going to be doable? I mean, why do you think this is not going to get totally tangled up with things where for example, here's the case that I would think is going to go wrong. You have a case where it's sort of an in-your-face symbolic limit issue, like the case of this unit step function. Fine, you can deal with that. What about if it creeps up on you by a series of 100 computations? You can know that if you were to do it symbolically, you know there's some limit to what can come out. But in a series of 100 computations, just following the error propagation calculus, you don't see that. See what I'm saying? Mm-hmm. I mean, can that happen? I don't know if that can happen. I think that has to be able to happen. I mean, can't I make this thing into some kind of sigmoid or something where it's like not so obviously, you know, let's say this is a thing which is a hyperbolic arctangent, right? So that it doesn't precisely, I guess that still has an asymptotic value. But something where there's a very slow increase as we go out here, right? Mm-hmm. I could invent something with a very, very slow increase, and then, you know, do I really, you know, then the actual limits are plus minus infinity because the thing has, you know, but it's really, really far out. Mm-hmm. And chances are within around, near the center, that you don't want to go out to that asymptotic, log n growth rate type thing.
Right.
I'm suspicious about whether this is possible. And the only question is, could we perhaps detect that something went wrong and generate a message or some such other thing, and then what do we tell people to do?
Well, these things are, in the end, effectively some sort of transform distribution, which is a very complicated integral. So I guess some sort of Monte Carlo method could be a generic solution. But yeah, it becomes.
I think it can be, but I mean, what we know already, because we have ways of just propagating exact probability distributions through operations, and we know that what happens there is the distribution gets incredibly fragmented incredibly quickly, and it is completely computationally infeasible to track every detail of every wiggle of the distribution as it's gone through 5 operations or something. And the whole point of this calculus of error propagation is you avoid that issue. You just say everything's sort of roughly approximated by a Gaussian, and there is a well-defined calculus of propagating the errors.
Right.
And this requires more thought. I think what we should do here, have you talked to, I don't know who's the most relevant, I mean, it's both Rob on the numerics side and Adam maybe on the algebra side. I think this probably deserves a separate kind of more math-oriented meeting to discuss.
Yeah, I've had several discussions with them, but none of them see an obvious solution.
No, there isn't. I think we can fairly say there is no obvious solution. Yeah. I mean, this is one of these things where, it's like saying we're doing machine precision arithmetic. Great. There are cases where machine precision arithmetic will fail. It's hard to tell when that's going to happen. And the effort to tell when that's going to happen is, triple the computational work. And if you want to be sure it isn't going to happen, well, don't use machine arithmetic. Use, arbitrary precision arithmetic, where we're checking all those things. But I think this might be the same type of case. If you're going to use automatic error propagation, then the pathological cases will not be covered, and there's just nothing we can do about it. I mean, this case here is, I mean, that's the life of calculus or something. I mean, this is just it's not. I don't really know what do you expect this to do? You expect this to use the interval computation where that, I mean, because this is working to first order, right? That's why it's giving you this result.
Exactly, yeah. So the derivative is totally horizontal, and it's giving a very small error. So this is a case in which the second order approximation or third order approximation would
but I mean, you can make me the nth order approximation, because I'm going to give you something which is, where the first n derivatives are all 0.
Yes, of course.
So I mean, you're never going to be able to win that. Right. Well, it's an interesting problem. I mean, look, I think it needs, if there's going to be a solution, it is not going to be purely a mathematical solution. It's going to be a solution that is a combination of messaging when we know something has gone wrong, even defining what it means to go wrong. Because, yeah, I mean, the question is, we were pretty careful to not define that a round is a Gaussian distribution. Because, it just isn't, and, it's not the way it works. Okay, there's a question here about whether if we specify a confidence level, will the confidence level propagate through computations? In other words, does the around?
No. So you can specify confidence level in input. It will be converted into a normal around. The computation will proceed, and then if you want to show it again, you need to use around form.
Well, so we could also have some option to around, which says what I am representing the 2 sigma level rather than the 1 sigma level, and then it could automatically come out in output. Because I mean, in a sense, okay, so then the obvious question is, what's the calculus of combining arounds? If you have an around that's the 1 sigma around plus an around that's the 2 sigma around, what do you do?
Right. So I have explicitly tried to avoid that, following numbers and quantities. So trying to separate the mathematical content from the display content. I think it's going to become really complicated if we try to merge the two things.
Okay, but let's take the following question. Okay, let's imagine that you've got a 2 sigma around that's given an input.
Yep.
So in your interpretation that this is all Gaussians, what you should do is to halve the value, halve the delta, and stick it in as the 1 sigma, as around x plus or minus delta.
Exactly.
And then say, oh, by the way, this was supposed to be displayed as a 2 sigma around. So upon display, show 2 delta rather than just delta. And that's a way you could do it. Now, the problem is what happens if you say a 1 sigma around plus a 2 sigma around? What do you do? In other words, who wins the display?
Mm-hmm. Right.
What do you think? What would the right answer to that be? I mean, in other words, a very weird case would be a single 1 sigma around plus a bunch of 3 sigma arounds. What should win the display?
I think there should be some canonical one, probably 1 sigma.
Okay, but if they're all 3 sigma, what should it do?
We might preserve the 3 sigma. But anyway, I'm not. That means we would have a different result for a round form of a round plus a round form of a round. I'm not sure that's the right thing. This form.
But the question is it important to be able to say? I mean, in other words,
it's important at the end. It's for typesetting. When you are going to present your result in an article, you will worry about which confidence levels to show it. But during the computation, you don't care about it.
Yes. Well, fair enough. Fair enough. I mean, I think it's a little weird. That's one of the very few cases where you would have a typesetting wrapper that seems to have sort of mathematical significance, but actually has no effect on the internal structure.
Well, imagine, for example, that we give errors all as percentages. Does that mean that we want the error back as percentage too?
I don't know. How do you give the errors as percentages? You do it with scaled, right?
In input right now as scaled, but we don't have right now a way of presenting the result as 30% error. And in some areas, like with resistances and things like that, they typically give errors with percentages.
Okay, so you're saying that a round form would have the possibility of giving a percentage error.
Exactly. 5.0 plus 30-something%.
And your point is that just because you entered it in percentage form doesn't mean you necessarily wants to come out in percentage form.
Right. This
well, just like,
yeah.
I mean, what happens in the case of numbers, there are cases where you can enter it in some, in other words, it doesn't care whether I entered the thing as, star wedge 3, it still just gives me that.
Right. Or a computation, if the original thing was given in, I don't know, scientific form or engineering form or whatever.
Mm-hmm. Okay. All right. Let's try and just have a quick look at some of these other things here.
Yeah, these are all big projects that probably require their own.
Definitely.
But...
Okay. Ben on our live stream is making a comment here. Okay, he's complaining about Dataset. Exporting a simple dataset as an Excel file does not come out correctly like it does with a CSV file. Oh, that's interesting. Well, it should. I mean, in other words, a dataset that is of the right depth to be exported as an Excel file, because Excel, at least in the current time, the future might be different, doesn't support higher depth tables.
Mm-hmm. Right. If it has the correct structure, it should work.
I think it's just a bug.
Yeah.
Maybe Devin, maybe you can propagate that to Shadi and her people.
Yep, sure.
Okay. Oh, good.
Yes.
That's nice.
So there are several projects going on with Dataset, and the first two are the most important ones, in my opinion. And then, of course, we need to improve the documentation And Chris is going to be working now on having better, more predictable layout. Sometimes with Dataset, you just try to see what's going to do, and it's not easy.
Right.
So,
look, I think that the this is really important if we can get that to work. Is that an active project now?
yes, I'm meeting with Leonid regularly to learn about his streaming project, which is very interesting.
Right. Well, it'd be great to get that. I mean, that project was almost finished several years ago and never really got connected in. Look, I think, to my mind, the big thing to figure out with Dataset is how to make it easier to use. I mean, it is a, it's basically high art of functional programming right now to do sophisticated things with it. And
yes,
people find that quite difficult. And the question is whether we can provide user assistance capabilities with auto-completions and things like this to help that, or whether we can use natural language, or whether there's a different idea. And I think we should try. What we should probably do is get a meeting where we've got a bunch of examples of dataset queries and try to understand what it would take to make those easier for people to enter. Maybe Chris could assemble that. Just a collection of like 50 dataset queries. Okay, Ben on our live stream, is commenting with just the Titanic dataset fails to export properly to Excel. Got to feed that to Shadi's group and get an answer to that. That sounds horrible. Okay, quickly here.
Yes.
More axiomatic systems. I think that would be nice. I mean, we have that student who was interested in working on that. I think that's something to do there, I would say.
Yep.
I mean, in terms of, clearly that's a much more niche thing than Dataset, but it's something that'll be nice to see move forward. More groups given by relations. So I mean, the current way of representing a group by relations, to me, is completely non-computable, right? I mean, if I say, finite group data, give me a group. What's a good group? Icosahedral group. And what do I say here?
Defining relations.
Okay. So, I mean, that's magnificent, but not very computable.
Right. And that's why now we have this way of getting it via axiomatic theory.
How do you do that?
So it would be axiomatic theory, list group actions, icosahedral.
That doesn't autocomplete. Somebody should report that. Oh.
Yes. So these are the same, but expressed. And you can also say with an association, the multiplication is P, the unit element is something else. So you can control the actual heads here.
What was the thing I was trying to do recently for which this was, I think I had my homemade calligraph generator that I was trying to use something like this on.
Yes, but now, of course, going from these relations to the group itself is very complicated. We will not have the functionality to do this.
That's this. Is that the Todd Coxeter business or something, or what is that?
Yes, that's part of it. Yeah.
But to go, in other words, if I just write down a random set of generators and relations, you're saying most of the time it's really hard to figure out what's equivalent to what. I mean, aren't you ultimately having to solve the word problem somehow?
Yes, and in fact, given a set of relations, you don't know even if the group is finite, for example.
Sure.
Sure.
I mean, actually, I was interested in ones that weren't finite, and I was interested in the calligraphs of non-finite groups.
Right.
Yeah, I mean, right. In fact, I put in the function repository this homegrown calligraph generator with it's an El Cheapo word problem solver. Okay. There's a question here on live stream from Peter. Will the lattice of subgroups be added in finite group data? A reasonable suggestion.
Yes, we should have that. We have now the list of subgroups, but not the lattice. Yeah.
So if I say here, subgroups. Yeah, I mean, the other thing we really have got to do is to make these symbolic rather than just these weird list things.
Yes, this is the notation that always was there in finite group data.
I know that because this was built a long time ago.
Yep.
I mean, I think it's time for us to do something more symbolic, perhaps use entities, perhaps use, I mean, maybe we can't use entities because these are parameterized, like you have the cyclic group of 60 elements or something.
I think if you do entity of group, comma, or no, entity finite group, comma, one of these, it works already.
So if I say, what are you saying? If I say entity,
yeah, just write entity finite group, comma, one of these groups.
Okay, but so if I say alternating group of 57 or something here.
Mm-hmm.
Wow, what happens if I say? I mean, what happens if I say something like this? Huh.
One thing, finite group data is will try honestly to compute things. It may take a long time. The entity framework has some predefined data, and it will tell you immediately, no, I don't have that case. So
sorry. So if I say this and then I say something like calligraph of that.
Yeah, no, that's not going to work.
But if I say calligraph of this, you're saying that will work.
Yes. No, sorry, that doesn't work either. What works is finite group data of alternative group 6, calligraph.
Why doesn't this work? What does calligraph usually eat as an argument?
It has a symbolic notation. So it's we have alternating group of bracket 6. So we have the symbolic.
Okay, so that's what I'm complaining about. That I'm complaining that these things should be turned into that symbolic form.
Yeah.
Maybe we can define that as a project. I mean, that doesn't seem super difficult. Beautiful.
Right. So so finite group data handles many more groups than we have in symbolic form, because in symbolic form we have right now the ones that we can handle via permutation groups. Many of the groups in finite group data are groups that naturally are given via matrix groups.
Yes.
Groups of Lie type. And
right.
we don't have representation, symbolic representation for those.
Right. Okay. All right. Quickly going through some of these other things. All right. So there's some things to be done here. I think we should investigate whether some of these interns/students are relevant for this.
Mm-hmm. Yep.
The dates. Oh yeah, I'll be very happy to see. Is this in 12.1, the new typesetting?
It's not in 12.1. There's still some additional work being done on it, but it's basically ready to go. We just need to get the final design sign off.
Okay, but that will be nice.
Yeah.
Data array. Yeah, we kind of know that. Date select. Huh. We haven't talked about that design, have we?
We've talked about it a little bit. There's a futurist ref page. I know we need to wrap up here, but basically the idea is to use parameters you can have from date value as a selection criteria. So you could specify holidays like that, or say, I want October 14th on odd years, or, basically supply arbitrary criteria and then either specify a select list of dates or a date interval and be able to do sub-selection from there.
Right. Okay. Calendars. Yeah. Young Christopher was just doing something on some Babylonian calendar, which apparently is, which basically is just tabular because it depended on when some Babylonian king decided to reset things and so on. But how far are we going to go with calendar? How far are we going to go with these calendars, and what are we going to do in cases where? Well, go on. You were going to say.
We have collected of the order of 40 or 50, and it's just a matter of sorting them in order of priority and having somebody implementing them one by one.
Okay. I did notice that in our natural language stuff, I was looking at Okay, the thing I was looking at was something very weird, but let's not. I'll tell you what it was. It was funny. Okay, what is that? What on earth is that? What on earth is that?
No idea.
Okay. Okay, so I think this. What happened there? Maybe, oh, that's because that came up and then that's the wrong behavior. Devin, can you report that as a bug?
Yeah, I got the screenshot.
Okay, see, that should not immediately just decide that it is Gregorian, extrapolated Gregorian dates.
Right.
That's wrong. It should have an assuming there. Okay, who wants to know why I was trying to figure out that date? Nobody.
Why?
Because it turns out there's a character called Saint Wolfram, believe it or not, no relation, who lived in 703 AD. And I was trying to work out, I had just was trying to work out the feast day of Saint Wolfram, but it was all confused because it isn't even clear what year he lived, died, whatever. But anyway, that was how I ended up with that date. He was an extremely minor saint, I would say. Anyway, okay, quantum computing we're actually just about to do, and people who are on this live stream might be interested in that. In about 15 minutes, we are going to be doing a discussion about quantum computing. So that is coming there. Trees is now underway. Is that a correct statement?
Yes, we have started also looking at the compiler version of a data structure of trees. That's going to be very useful to do operations. And yeah, so there are now the three worlds of what Xavier started with tree element, the graph version, and the compiler version. So it's going to be interesting to move between the three of them.
I hope with a good definition of the word interesting. Okay. All right, combinators, finally, we've talked about several times. I mean, the real issue with combinators is it's a whole story of evaluation. I mean, look, it would be nice to do something. This is the centenary of combinators. It would be really nice to be able to do something with those. The issue, as we keep on discussing, is evaluation.
Right.
And I mean, strangely, really strangely, that dovetails, as you know, with my physics project, which ultimately is all about the relationship between reference frames and evaluation orders. And we should understand something. We should have a sort of profound new understanding of what it means to do concurrent computing and what it means to do different kinds of evaluation orders as a result of kind of the parameterization of frames. But we don't yet have that. I mean, it'll be quite amusing. I mean, I think we'll get things that are the analog of various kinds of coordinate systems and so on that represent different, essentially, evaluation fronts in one of these systems. And I think that's a super interesting direction, but it is definitely high science, math, computer science, whatever you call it, to solve that. And that's kind of what we need to do combinators well. Okay, there's a comment from Mohammed on our live stream that Dataset gets cropped in the new Windows front end. That's upsetting to hear. Somebody check into that.
Yep.
Okay, we got to wrap it up. Good. Well, we should be back on track for doing these ILD meetings, I hope. And for those on this live stream, as I say, at hour roughly, we'll be talking about quantum computing. And thanks to everybody here. Thanks to people on the live stream. And see you all soon.